All right, let me put my mug up here. Whoops. Oh, it's going to shut down. I've gotten a lot of questions on this particular problem, this homework 11, homework number 2, problem 11. All right, where we've got a dragster taking off from and it's a crucial problem that we know how to do. All right, that we know how to analyze it. And I think one of the problems, so I'm going to go ahead so welcome. I'm just going to send this out to you. I'm going to email this to you, and I'll be on Blackboard too. But anyway, here, let's take a look at what the problem looks like. Here it is. It says some of the fastest dragsters, called top fuel dragsters, race from 30. And I thought we might have done this in class, but after the light turns green, the dragster completes a 400-meter race in a time of 8.6 seconds. Okay, so a lot of people were getting this wrong because they were saying this. Let me get the x equals 400 and the time is equal to 8.5 seconds. Okay, first of all, let's just start here. There we go. A lot of this is wrong. This is wrong to go, oh, well, if I know that it went, what was I supposed to find? Its acceleration. So if I know it went 400 meters in 8.5 seconds, therefore its speed, its velocity is 400 divided by 8.5 seconds. Therefore its speed is that. Gosh dang it, I always start these things before I have my calculator. Son of a gun. Dumbass awards already started on Monday morning. Okay, so I got 400 divided by, let's make sure we clear all that. 400 divided by 8.5. Okay, so you get 47 meters per second. And then you say, okay, well then the acceleration would be 47.1 meters per second divided by 8.5 seconds, because I'm going to get meters per second squared. I get 5.53 meters per second squared. That's just wrong. This whole idea is wrong. Why? Because we're assuming here, we make the assumption that it's going at a constant speed. This assumes a constant speed. That's wrong. It's not. It's accelerating. It started at 0. V naught is equal to 0. V final, I don't know. The time I do know, 8.5 seconds. Acceleration, I don't know. Okay, so I've got these two unknowns. Distance, I do know. So I got a lot of information here. Now, it asks for the acceleration. We could have started off with the wimpy problem, with the wimpy formula, which I don't like. I just don't like. Let's just start off with the Manly problem, where we find it, where we're going to find the acceleration. And I'll show you. Here's method 1, real quick. Method 1, we go, okay, x is equal to x naught plus v naught t plus 1/2 at squared. Okay, I'm trying to find a. I know this guy's 0, so that goes away. This guy's 0, so that goes away. So I've got 400 is equal to 1/2 at squared. 2 times 400, multiply both sides by 2, is equal to a times 8.5 squared. So I get 800 divided by 8.5 squared, and that comes out to be, well, it'll be like around 800 divided by 70 something, because this is bigger than 64 and less than 81. So I'd say 8.5 squared is right around like 77. 72.25. Okay. So anyway, so I take 800 divided by that answer. Boom. Whoops. Equals 11 Let's go with 11.1 meters per second squared. Now that's a pretty big, that's bigger than pulling more than a G. And that's the average. And actually what dragsters do is they pull about 5 Gs for a very short amount of time. They can't accelerate for that long, you know. So that's how many Gs they pull on average for the entire 400 meters. But see, what happens is they kind of stop accelerating. It's a big explosion, and then the acceleration is not constant. The initial acceleration is about 4 times that. But that's how you do it. Method 2. Then once you get these, the others come in handy. Okay. Method 2. You could use this equation. V final squared, which I don't know, is equal to V naught squared. Oh, plus 2A times 400 minus 0. Oh, we can't use that one. We can't use that one because I don't know what the acceleration is and I don't know what that is. So, no method 2. But that's how you do it. That's how you do it. So, since I got you on the hook, let's just go ahead and here are your equations. Here are your equations for for practically the entire test. Okay. So for your formula sheet should contain these guys. The formula sheet should be x is equal to the average velocity times time, where the average velocity is equal to v naught plus v final divided by 2. And we know that x is also equal to, this is all assuming constant acceleration, x naught plus v naught t plus or minus 1/2 at squared. And we know that v final is equal to v initial plus at plus or minus at. And we know that the acceleration is equal to v final minus v initial over the time. And last but not least, you got v final squared is equal to v naught squared plus 2a times x final minus x initial. And when you're doing free fall problems, you just plug a y in there. Okay? And if the acceleration is negative, then you put a negative sign. Minus 1/2 at squared. V naught squared, v final squared is equal to v naught squared minus 2a times x final minus x initial. It's that simple. All right? I mean, it's not simple. That was a dumb thing for me to say. It's not simple. It takes some work. It does take some work. What's the rest of the problem look like, though? If the dragster could, oh yeah, if it could keep that acceleration, 11.1 meters per second squared, man, that thing will be flying. Okay? So in part B here, in part B, the acceleration we figured out was what, 11.1 meters per second squared? All right? And so if we could keep that up for 1,600 meters, we can find its final velocity. So I know that this is, so I'm going to find its final velocity, and then I'm going to take the average velocity and figure it out. Well, or you could do this one. You could do v final squared, is what you're after, is equal to 0 squared plus 2 times 11.1 times 1,600 minus 0. That would work. Then don't forget to take the square root now. That's one way. See, physics is a wonderful thing. There's one method for doing it. Here's another. You could go, well, I know the acceleration, so I can take v final is equal to the acceleration times the time, which I don't know, but I do know how far it went. So is equal to v naught plus the acceleration times the time, where v naught is equal to 0. Gosh dang it, v final is equal to v naught plus the acceleration times the time. And I know that v naught is equal to 0. And I know the acceleration, but I don't have the time. But I do know this. I do know that the average velocity times the time is equal to 1,600 meters. Does that get me anywhere? Oh, what it's going to do is it's going to wind up giving me this equation right here. Or I can figure out the time. Oh, sorry. I can also figure out the time where I know that the time is equal to, I see this is like method 3. This is method 2. Sorry. So V final is equal to this, where I know that the time, that 1,600 is equal to 1/2 times 11.1 times the time squared. So I get 2 times 1,600 divided by 11.1, take the square root of that, I get t. And then I'll say that V final is equal to the acceleration times the time, times the square root of 2 times 1,600 over 11.1. Square root of that. That would do it. These two guys will get you the same thing. All right, out of here.